Hi, today we try to see how we solve question based on repetition of digits. I am again repeating, it's repetition of digits, not the number. We'll check two questions and we'll see how we can solve these questions. Our first question is, if 7 times 7 is divided by 41, what would be remainder? We can apply Euler in these type of questions, but Euler is not effective if the repetitions of number is smaller. The Euler of 41 is 40. If this number is multiple of 40, we can solve, but this is not a multiple of 40. So we have to remember a few other things. Our second question is, if m is a n-digit number repetition of 7 or any digits, then what is the least value of n for which this m is divisible by 7, 11, 13, 37, 41 and 271. So we want the least number of n for which the repetition allowed for all these 6 primes. Before solving this, I am just repeating one thing. I am not going to tell you the concept. It's just few basic observations. Okay. So the first observation is, if the repetition is of 7 times, we can say this is nothing but the repetition of 1 7 times and extra 7. So the repetition of digit is nothing but the repetition of ones. Check few observations on the repetition of 1 and apply this in the question. This is the few series of the repetition of ones. I just suggest to you, please remember this chart. The 11 is 11. The factor of 111 is 3 into 37. 37 comes first in this series. So the root of 37 is repetition of 3 ones. Means if any digit repeated up to 3 times or 3n times should be divisible by 37. 11 an old entry, we have 11, so this is not the defining rule for the 11. If any digit repeated up to 4 times or 4n times should be defined by 1001. If any digit repeated up to 4 times or 4n times should be divisible by 1001. Again check 41 and 271 new entry. We have 5 ones, so any digit repeated up to 5 or 5n times should be divisible by 271. Again the new entry is 7 and 13. So any digit repeated up to 6 times or 6n times should be divisible by 7 and 13. And we have 8 ones. For the 8 ones we have values called 73 and 137. If any digit repeated up to 8 times or 10 times should definitely be divisible. This chart would definitely help you throughout in your competitive examination. If you remember this chart, you can solve many questions based on the repetition. I accept Euler's always help, but not for the smaller values. So by using this chart, let's solve our first question. Our first question is 7 repeated up to 7 times divided by 41. We know 41 comes with 5 ones. So any digit repeated up to 5 times or 5n times should be divisible by 41. We have 7 sevens, so just we need to remove 5 sevens because these 5 sevens gives remainder of 0. We just need to find the remainder for double 7 means 77. So 77 divided by 41 gives remainder 36. So this complete number divided by 41 gives remainder 36. If question comes from prime which is not in this series, how we can solve? If you have primes not in this series, believe me, it won't come in any examination if it is not based upon the Euler. Let's solve the second question. Our second question is, we have to check the divisibility for the 7, 11, 13, 37, 41, 271 when the repetition of digits. We know for the 7 digit repeated in the form of multiple of 6. For the 11, multiple of 2. For the 13, again the multiple of 6. For 37, we need multiple of 3. For 41, we need multiple of 5. For 271, we again need multiple of 5. So if we are going to check 7, 11, 13, 37, 41, 271, we need the multiple of 2, 6, 3 and 5, and we want the least value of n, so we want the LCM of 2, 3, 6, 5, and the LCM of 2, 3, 6, 5 is nothing but 30. So the least value of n is 30, for which m should be divisible by 7, 11, 13, 37, 41 and 271. Okay, thanks. If you have any doubt, feel free to ping me